when we look at component analysis, what we are essentially trying to do is identifying the components of an engineering system. And I would say not all components, but relevant components of an engineering system and its super system. So what is an engineering system and what is a super system? What do you understand by these two terms? I have not described them, I have not explained them, but if I am using these terms in this context, what do you understand of them? It's a question. What do you understand by the term engineering system or super system?
So engineering system means like those components who are like, let's say there is a product and there is like some part of the product which are used in or like engineering things actually. So within that engineering system there is some components is there. For example, if you consider for example a drone, then a drone is like you are using its fan and everything, like all the IC and everything. So those are part of the engineering system, but it's not in final product. But if you consider super things, means it's the entire product you're going to talk about. It's all the hardware and software, like everything is like going to combine actually. Making it
Okay.
like,
Yeah, thank you, Biman. You're taking us closer to the answer. Anyone else?
So basically, if we talk about some medical product, so here what a machine involves is the basically a engineering system, and how a machine responds to a particular medical case, that involves the complete basically involves a medical system also. So in a whole, we can talk it as a super system, but where the machinery part is there, we can basically call it an engineering system.
Okay, good. More ideas?
Hello, sir. Sir, if we talk about how hydroelectricity is generated, then it consists of turbine and which is connected to a means uh, AC synchronous motor. So that there is a mechanical system as well as a electrical system, but combined whole system is acting as a engineering system, something like that.
Okay. And what is a super system? So Vrinda is saying super system is something that involves the environment or external interactions. Thank you, Vrinda. This actually does take us forward. What else?
So maybe super system involves all the components interacting with the actual system as well and how they are affecting.
Okay. So let's take the example of that extra appendage for the tractor, which could be, so over there, that extra that appendage that you want to work on, or that plow, or that uh, harvester that we want to work on, that is the engineering system. Okay. And the crop, the stubble that needs to be cut, the ground on which the tractor would move, the person who will drive the tractor, all that is the super system. The engineering system is a product which you can possibly go and purchase, that you're going to offer. Super system is the context and other people and everything else around or in which the product would be used. Other interactions that are happening there also form a part of super system there. Okay, so what we are saying is that the component analysis, we first identify the components of an engineering system and then also of the super system. For example, this drone would be carrying a payload. That payload is a part of super system. It would be rising up in the air. So air is a part of super system. Can your drone function in vacuum? No, it does require air, but you don't need to sell air along with the drone. The air is available in the super system. Are you able to see this? Is the distinction between engineering system and super system clear now?
Yes.
So please explain
Yes.
it once again.
Okay. So whatever product you want to update, that product, let us say, is the engineering system. So we wanted to make a drone. So the body of the skeleton of the drone, the blades of the propellers, the remote, the wires, the display, the connecting stuff, everything, they are all a part of the engineering system. Now you are making this drone for a particular purpose. You want to, for example, capture images of a particular landscape. Now that landscape is now the super system. Air, because to take a lift, you will need air. Otherwise, the drone cannot fly. So air is a part of super system. So something that you're making that you will sell to the customer as a product is the engineering system. Other things that the customer may already have or may add or may anyway pervasively exist are a part of the super system. That is the context in which your engineering system is operating. Clear? Any
Yes,
questions?
Yes, sir.
Okay. So we identify system and super system components. And these components could be two things, could be substances or fields. So substance समझ में आता है, they are objects with a rest mass. So when I showed that drone, and that drone, I was showing the substances as the blades, the wires, the battery, and everything. And what we are saying is, when we are identifying these components, we should also identify fields that are there due to these components and with which the engineering system is interacting. For example, in the context of a drone, what field would be there?
So gravity.
Gravity. In terms of a magnet, that field is the magnetic field there. Abhi, he was talking about hydroelectricity. So the magnet that is there in the synchronous motor, you can actually talk about that, because when you talk about the magnet, when you talk about how it is interacting with the with how that mutual inductance is coming into picture and so on, only then you will be able to improve the synchronous motor there. So when you talk of engineering systems, you talk of two types of components, those which are substances and those which are fields. Now, how to do the component analysis? So the first step in component analysis is creating a hierarchy of components. For example, when we were talking about the car just a little while back, we said a car would have wheels, the car would have its body, the car would have its engine, it would have a fuel tank, it would have this. So these are components at one level of hierarchy. Now, I could also say that the engine of the car has a chamber, it has a piston, it has an electric plug, it has valves, it has so many things. Do you realize that when I talk of the components of a car, I did not talk about the valves inside the engine? Because when I'm talking about the car and identifying which part of the car is faulty, I want to look at the components at the hierarchy of the car only. Once I identified that the engine is faulty, that is when I'll go deep and say, what are the components of the engine? Now, even in this, I may go and say, what are the components of the transmission? And I could say, okay, there is a rod, there is a cantilever, there is this, there are 4 nuts, there is this kind of a thing, and they will become a lower hierarchy of components. So we create a hierarchy of components. What hierarchy are we looking at? Are we looking at the full car, the components of the car, or sub-components of those components? Okay, we select where we are working at and then identify the components at the selected hierarchical level. I will give you an example. car. At the second level, there are electrical. So when I say of a car, I say, okay, there is electrical system, there is a steering system, there is a fuel system. Now, I may say that electrical system has an alternator, a voltage regulator, and a battery in it. And then I could say that the battery has electrodes, electrolytes, and casing. Huh? And now, whichever level I want to work on, I can do component analysis at that level. When I'm talking of component analysis at the electrical system level, I will talk only of alternator, starter, voltage regulator, battery, and so on. I will not talk about electrodes of the battery in the same component analysis. I will not talk about the transistors inside the voltage regulator in the same analysis. Are you able to see this? Any questions? Clear?
Yes, sir.
Yes, sir.
Great. So, natural question is, how do I select the right hierarchical level? So, you select the level based on project goals and constraints. A lower hierarchical level increases the analysis effort, but a higher hierarchical level may have only insufficient information, so you will not be able to solve the problem. For example, if you look at the case of this law wala system, that Lavanya was talking about. If you look at that case, at present they are at a very high hierarchical level. They're just saying Niti Aayog, they're just saying public, they're just saying this. So it doesn't have sufficient information. Where is the system failing? You need to go slightly deeper. You go to a lower hierarchical level and see where is the system failing. Only then you will be able to solve the problem. Again, as I already mentioned, you have to ensure that you select components at the same hierarchical level only. You cannot have alternator and electrodes of a battery in the same component analysis. Okay. Now, when I say electrodes of a battery, how many of you have actually opened up a car bonnet and looked at the battery, or why just a car bonnet? Many of you may have those inverters at your home and battery associated with it. How many of you have looked at the battery? Do you know how many cells are there in a battery?
So around 8.
Yeah, could be from 6 to 12 also, depending on
Yes.
what is the capacity of the battery. So now I could say that all these electrodes or all these cells are exactly the same, and therefore I want to put them as only one. Okay, so there are cells in the battery. Or I could say that I am using 12 cells. So cell 1, cell 2, cell 3, cell 4, and so on. For example, if there are 6 nuts that are used in a system, you could say there's just nuts, or you could say 6 nuts. Why? Because the goal is to save costs, and reducing the number of nuts could be a solution. In case of a battery, reducing the number of cells could be a solution, and therefore you would want to say put all the 12 cells separately in your component analysis. And okay, if you realize that, the hierarchy at which I did my component analysis, I still do not know sufficiently enough as to which component to work on or what problem to solve, go back to the drafting table and do the component analysis at a still lower level of hierarchy. Okay. Is it clear till here? Because now I want to take you through an example, and then we will do some exercise ourselves. Any questions still here? Okay.